Tesla and electricity. What did you think about Tesla's initial idea that Westinghouse shot down to sort of broadcast electricity?
Nikola Tesla produced more than 300 patents and a trail of unpatented visions that still ignite curiosity today. He was not just a pioneer of practical electricity. He was also a dreamer who imagined death rays, thought-to-thought communication, wireless global power grids, and machines that resonated with the Earth itself. While much of the modern world runs on the technologies he brought to life, from alternating current to radio, other concepts remain cloaked in speculation and myth.
Nikola Tesla fan club somehow feel that he got wronged in his life, okay?
But now, quantum AI can help us recreate devices found in Nikola Tesla's lost sketches. This is one story you wouldn't want to miss. Let's get started. Alternating current. Alternating current is Nikola Tesla's greatest legacy and perhaps the most significant turning point in the history of electrical engineering. In the late 19th century, the world's cities were first electrified through direct current, or DC systems, championed by Thomas Edison. However, DC's practical range was severely limited. Power could not be transmitted efficiently beyond about a mile or two from a generating station due to resistive losses in the wires. Tesla, having studied engineering in Graz and Prague before emigrating to the United States in 1884, recognized that alternating current could overcome these constraints. By reversing the flow of current many times per second, AC enabled the use of transformers, which could step the voltage up for long-distance transmission and then step it back down for safe use in homes and factories. In 1887 and 1888, Tesla filed patents for his polyphase AC system, which included motors and generators designed to operate seamlessly with alternating current. George Westinghouse, a Pittsburgh industrialist, purchased these patents and hired Tesla to help develop the system. This set the stage for the War of Currents. The turning point came in 1893, when the Westinghouse Electric Corporation won the contract to power the Chicago World's Fair using AC. The spectacle of 100,000 incandescent lamps powered by Tesla's system electrified not just the fairgrounds, but the imagination of the public. Just 3 years later, the Niagara Falls Power Project came online, delivering hydroelectric power over 20 miles to Buffalo, New York, using Tesla's polyphase AC generators. It was the first long-distance, large-scale use of AC transmission, and it proved beyond doubt the superiority of Tesla's system. But Edison refused to admit defeat. On January 4, 1903, at Coney Island, New York, a circus elephant named Topsy was publicly unalived using alternating current. Edison's film crew from the Edison Manufacturing Company recorded the event in a short film titled Electrocuting an Elephant. Edison, a staunch promoter of direct current, sought to discredit Tesla's alternating current, or AC system, which was proving to be more efficient for long-distance transmission. In earlier campaigns, Edison's team had staged demonstrations electrocuting stray dogs, calves, and even horses with AC to brand it as dangerous. Ironically, Tesla's AC system won out despite the smear campaign. However, Tesla's dream of reshaping the world through his alternating current system was only partly fulfilled in his lifetime. On one hand, AC power became his greatest triumph. It won the so-called War of Currents. But for Tesla, this victory was bittersweet. While the world adopted AC power, Edison's influence and the business world's short-sightedness crushed Tesla's grander vision of a planet united by wireless energy. Though Tesla won the technical battle, Edison's relentless business maneuvering ensured Tesla never had the resources to scale his next big leap. The dream of global wireless power, embodied in his unfinished Wardenclyffe Tower project. That tower, which Tesla hoped would transmit not only messages but also electricity across the globe, was demolished before it could prove his ideas. But wait, there's a lot more from where that came. Radio communication. As early as 1893, Tesla demonstrated to audiences in St. Louis and Philadelphia the principles of transmitting signals without wires, describing in detail a system for sending messages through tuned circuits and electromagnetic waves. These demonstrations occurred years before Guglielmo Marconi made his first wireless telegraphy experiments in Europe. In 1898, Tesla filed a US patent for a method of intensifying and utilizing effects transmitted through natural media, which outlined concepts of resonance and frequency tuning essential to radio. He established a large laboratory at Colorado Springs in 1899, where he constructed massive coils capable of generating millions of volts. There, he carried out experiments in wireless transmission, successfully lighting lamps wirelessly at distances of up to 25 miles and recording signals from thunderstorms hundreds of miles away. Tesla even claimed to have detected extraterrestrial signals. Most historians, however, believe he had intercepted natural atmospheric or cosmic radio noise. Tesla envisioned a worldwide system of towers that could provide instant wireless communication and even a primitive form of broadcasting to any point on Earth. Unfortunately, financial support collapsed, particularly as Marconi succeeded in transmitting the first transatlantic wireless signal from Cornwall, England to Newfoundland in December 1901, using equipment heavily indebted to Tesla's earlier patents. In 1943, the US Supreme Court recognized Tesla's priority by invalidating several of Marconi's patents and restoring credit to Tesla's work in the field. By then, however, Tesla had died penniless in a New York hotel room, while radio had become a multi-billion-dollar industry. Today, every aspect of modern communication, AM and FM broadcasting, television, satellite links, Wi-Fi, Bluetooth, and cellular networks, rests on the foundation of wireless principles Tesla demonstrated before the 20th century began. His prediction that people would one day carry small devices to communicate instantly across the globe has been realized. Remote control. Tesla's genius for innovation also extended to remote control, an idea that seemed like science fiction at the end of the 19th century. In 1898, at Madison Square Garden in New York City, Tesla unveiled what he called a teleautomaton, a small, radio-controlled boat. Using a simple box with a lever, he demonstrated to stunned spectators that the boat could be maneuvered wirelessly, obeying his commands without any visible connection. Many in the audience suspected trickery or hidden wires, but Tesla explained that his device relied on radio signals transmitted and received by tuned circuits. The patent for this invention was filed in 1898 and became the first in history for a radio-controlled apparatus. Tesla spoke openly of fleets of unmanned vehicles that could carry out tasks too dangerous or monotonous for humans. Although Tesla's contemporaries dismissed the idea as a novelty, his remote-controlled boat prefigured entire industries. In the 20th century, militaries developed radio-controlled torpedoes, reconnaissance aircraft, and guided missiles, building directly on the principles he had demonstrated. By the Second World War, radio-controlled drones were already in use, and today, unmanned aerial vehicles are central to both civilian and military operations. From military Predator drones patrolling conflict zones to quadcopters delivering packages for Amazon, all trace their lineage back to Tesla's teleautomaton. Beyond aviation, robotics, and the Internet of Things embody Tesla's vision of machines obeying wireless commands, from autonomous vacuum cleaners to remote-controlled surgical robots. The simple demonstration at Madison Square Garden in 1898 proved to be the first glimpse of a world where remote control, automation, and wireless communication converge. Fluorescent and wireless lighting. In the early 1890s, Tesla presented to audiences in New York and Philadelphia a series of high-voltage, high-frequency lighting experiments using gas discharge tubes. These lamps contained no filaments and glowed when exposed to the electromagnetic fields generated by his coils. Unlike Thomas Edison's incandescent bulb, which relied on a heated wire filament sealed in glass, Tesla's lamps produced light by exciting gases with oscillating electric fields. At the 1893 World's Columbian Exposition in Chicago, Tesla and Westinghouse engineers used his AC system to power more than 100,000 incandescent bulbs. Tesla also exhibited prototype fluorescent-style tubes bent into shapes, including letters spelling out names and phrases. These displays, decades before neon signage became commercially available, gave the public its first glimpse of what light without filaments or direct wiring might look like. modern neon signs, which debuted in Paris in 1910 when French engineer Georges Claude demonstrated neon-filled discharge tubes, owe a conceptual debt to Tesla. By the 1930s, fluorescent lamps became commercially viable through General Electric's development of phosphor-coated tubes energized by mercury vapor discharge. Today's LED technology, introduced in practical form during the 1960s, represents an even further leap, using semiconductors to produce light with minimal energy loss. While Tesla did not create neon or LED lighting, his experimental lamps and wireless demonstrations established the principles of gas excitation and field-driven illumination. These later technologies were built upon these concepts. Wireless power transmission. Tesla's interest in wireless lighting naturally extended to the broader problem of wireless power transmission. The most iconic embodiment of this dream was the Wardenclyffe Tower, constructed beginning in 1901 at Shoreham, Long Island. Designed by architect Stamford White and financed in part by J.P. Morgan, the 187-foot-tall structure combined a steel frame with a large copper dome nearly 68 feet in diameter. Tesla envisioned it as the first node in a global network of towers that would transmit both information and power through the Earth's natural conductivity. In his view, it was possible to excite the Earth's resonant frequencies with high-voltage oscillations, allowing electrical energy to be distributed wirelessly to any receiver tuned to the same frequency. Tesla insisted that the system could light entire cities without wires and enable instant worldwide communication. The reality of Wardenclyffe was less triumphant. Construction costs escalated. Morgan grew wary of investing in a project that threatened to undermine his control over wired telegraphy, and Marconi's successful 1901 transatlantic radio transmission diminished Tesla's claims of priority. By 1906, financial support had collapsed, and the unfinished tower stood idle until it was dismantled for scrap in 1917. In 2007, researchers at the Massachusetts Institute of Technology, led by Marin Soljacic, successfully demonstrated Wi-tricity, or wireless electricity transfer, using resonant magnetic coupling. Their setup transmitted 60 watts of power across a 2-meter distance with about 40% efficiency. This is enough to illuminate a 60-watt light bulb without wires. This breakthrough drew directly on principles of resonance that Tesla had described more than a century earlier. The technology has since been commercialized by companies such as Wi-tricity Corporation, which has partnered with automotive manufacturers, including BMW, Toyota, and Hyundai, to develop wireless charging pads for electric vehicles. Wireless charging for smartphones, based on inductive coupling standards such as Qi, has already become ubiquitous in consumer electronics. However, large-scale, long-range wireless energy transfer remains elusive. Efficiency drops sharply with distance, and safety concerns about strong electromagnetic fields limit practical applications. Research by the Japan Aerospace Exploration Agency, or JAXA, in 2015 demonstrated the wireless transmission of 1.8 kilowatts of power over 55 meters using microwaves, with the long-term goal of harvesting solar energy in space and beaming it to Earth. The idea of space-based solar power, first proposed in the 1960s by Peter Glaser, echoes Tesla's dream of limitless wireless energy, but faces enormous engineering and economic hurdles. While small applications flourish, from wireless chargers to experimental vehicle pads, Tesla's global wireless grid remains an unfulfilled vision. Well, at least for now. Bladeless turbine. Patented in 1913, Tesla's turbine design eliminated the traditional blades found in steam and gas turbines. Instead, it employed a series of smooth, closely spaced discs mounted on a shaft. Steam or compressed air was directed tangentially onto the discs, and the boundary layer effect, whereby a fluid adheres to the surface of a solid, caused the discs to spin, transferring energy to the shaft. Tesla believed his bladeless turbine could achieve higher efficiency and lower maintenance than conventional turbines, with applications in power generation, pumps, and even automobiles. In practice, however, the bladeless turbine proved less efficient than expected. The boundary layer effect was real, but viscous losses and material limitations of the early 20th century prevented the design from outperforming bladed turbines. Tesla constructed small prototypes, some of which reportedly achieved speeds of up to 35,000 revolutions per minute, but no commercial-scale adoption followed. By the 1920s, bladed turbines developed by companies such as General Electric and Siemens had become dominant in power generation, leaving Tesla's design as a fascinating curiosity. In recent decades, renewed interest in Tesla's turbine has led to experimental reconstructions in laboratories and universities. Researchers have found that while the turbine runs smoothly and quietly, its efficiency rarely exceeds 40% under load, compared with more than 90% for modern bladed turbines. Nonetheless, some studies suggest potential niches where Tesla's design might be advantageous, such as micro-power generation from low-pressure fluids, or as a compact pump in medical or industrial applications. Earth resonance and global communication grid. In 1893, during lectures in St. Louis, Philadelphia, and at the Franklin Institute in Philadelphia, Tesla first articulated the idea that electrical energy could be transmitted wirelessly, not only through the air, but also through the Earth. He believed that the planet behaved as a giant conductor with natural resonant frequencies that could be excited using powerful oscillators. If tapped correctly, these resonances could, in his words, make it possible to send intelligible signals or quantities of energy to any point on the globe. Tesla pursued these ideas most dramatically at his Colorado Springs laboratory between 1899 and 1900. There, on a site near Pikes Peak, he constructed an experimental station equipped with a massive coil capable of generating voltages of more than 12 million volts. His Colorado Springs notes, later published in 1978, describe experiments in which he lit incandescent lamps without wires at distances of 25 miles and observed electromagnetic disturbances he attributed to Earth resonance. For Tesla, these experiments validated the principle that the Earth could be set into electrical oscillation, a phenomenon he hoped to exploit for both wireless power transmission and global communications. However, he failed to realize the concept in his lifetime. Modern global communications followed a very different path than Tesla imagined. The first practical transatlantic telegraph cable was laid in 1858, and by the mid-20th century, undersea coaxial cables and satellites had become the backbone of long-distance communication. Today, the world relies primarily on fiber optic cables, which transmit pulses of light through glass fibers with minimal loss, and satellites that orbit hundreds to tens of thousands of kilometers above the Earth. Presently, more than 1.3 million kilometers of submarine fiber optic cables connect continents, carrying over 95% of international internet traffic. Satellite constellations such as SpaceX's Starlink and OneWeb provide additional coverage, especially in remote regions, using radio frequencies and low Earth orbit platforms rather than Earth resonance. Although Tesla's method of global communication through Earth resonance was never realized, elements of his thinking remain relevant. The Earth does indeed have resonant frequencies, known as Schumann resonances, first measured in 1952 by physicist Winfried Otto Schumann. These resonances occur at extremely low frequencies around 7.83 Hz and higher harmonics, sustained by lightning discharges in the atmosphere. While they are real, they are not practical carriers for high bandwidth communication or power transmission in the way Tesla envisioned. Nevertheless, his conceptual leap that the planet itself might be part of a global communications system anticipated humanity's eventual construction of a worldwide network. Instead of Earth's natural resonances, we achieved it with engineered infrastructures of glass and satellites. Tesla's dream was not wrong in spirit, only in the mechanism. Isn't it remarkable how one man's vision can foreshadow today's interconnected world? However, a lot of Tesla's dreams remain just that, dreams. Technologies, unrecreated, and the role of AI. The most infamous of Tesla's unrealized inventions is the so-called teleforce, often sensationalized as a death ray. In the 1930s, Tesla gave interviews describing a directed energy weapon that could project concentrated beams of particles capable of downing aircraft at distances up to 200 miles. On July 10, 1934, the New York Times ran a headline titled "Tesla at 78 Bears New Death Beam," where he claimed his device could end warfare by making national borders impregnable. Tesla never demonstrated a prototype, and his description has never been linked to a working machine. Scholars argue that the principle sounded like a mix of particle accelerators and charged plasma streams, both fields still in infancy during Tesla's lifetime. Today, militaries experiment with high-energy lasers, microwave weapons, and electromagnetic railguns, but none replicate Tesla's claimed performance. The Soviet Union allegedly showed interest in his designs after he died in 1943, when the FBI seized many of his papers under the Office of Alien Property. Yet, no authenticated Teleforce device has surfaced. Tesla also envisioned machines that could transmit thoughts directly from one mind to another. As early as 1893, in a lecture in St. Louis, Tesla hinted that human thought might one day be transmitted instantaneously to any distance. By the 1930s, in his later writings, he described the possibility of building instruments sensitive enough to register mental impulses and project them outward. No physical model of such a thought machine ever existed, and the idea was far beyond the neuroscientific knowledge of Tesla's era. Yet his musings prefigure modern experiments in brain-computer interfaces. In 2019, Elon Musk's Neuralink unveiled a prototype implant designed to read neuronal firing patterns, with clinical trials for human patients beginning in 2023. Tesla also made provocative claims about controlling the weather and even triggering artificial earthquakes. In 1898, he demonstrated a small electromechanical oscillator at his New York laboratory, which allegedly shook his building so violently that the police were called. Tesla later boasted that if scaled up, such a device could split the Earth in two by resonating with its natural frequencies. In later years, Tesla suggested that electromagnetic manipulation of the atmosphere might alter weather patterns. The US High-Frequency Active Auroral Research Program, or HARP, founded in 1993 in Alaska, used ionospheric heating to study radio propagation. Although HARP's stated mission was purely scientific, conspiracy theorists often connect it with Tesla's supposed weather modification ideas. In any case, artificial intelligence has now become a new tool for reimagining Tesla's unfinished visions. Researchers have trained neural networks on his incomplete patents and sketches, using them to reconstruct missing parts or simulate how his devices might have worked. Hobbyists and labs have even built prototypes based on these AI-generated blueprints. These experiments show how AI can extend Tesla's ideas beyond the limits of his time. The next leap lies in quantum AI, which could analyze billions of design variations simultaneously. With processors like Google's Sycamore already proving such speed, Tesla's notes could be transformed into fully tested models of wireless resonators, bladeless turbines, or even fragments of his global energy grid concept. While myth and science often blur in these efforts, AI ensures Tesla's sketches are not relics, but seeds for future machines. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.